I am moving from here to here. The rising voltage is AV1. From here to here, obviously this is the direction of current from top to bottom. From this terminal to this terminal, there will be a rise in potential because current actually will flow from a higher potential from a lower potential. Okay, since current direction I1 through this branch is downward and we are moving against the direction of current, so there will be rise in voltage. So plus V1 minus a V1 by 2 is the current, that multiplied by 1 is the voltage. So a V1 plus V1 minus a V1 by 2, this is the voltage across this branch plus this voltage. That means a V1 plus this voltage means calculated here plus this voltage B times I1 is the Thevenin voltage. And that if you simplify, it will be V1 by 2 into 1 plus A plus B minus AB1 minus AB, sorry. So you see in figure F21.5, this gives you the circuit. The terminals are already open. So if we calculate the voltage across the open terminals, then we shall get the Thevenin voltage here. That is calculated here. Now you tell me whether it is clear to you or not, whether you could follow, every one of you could follow this example up to this determination of Thevenin voltage. Any question here up to this? Is it clear to all of you?
Yes, sir. আমার একটা কোশ্চেন আছে স্যার।
হ্যাঁ বলো
স্যার পেজ 17 একটু যান।
পেজ 17 আচ্ছা, পুরনো কোশ্চেন তাই তো?
হ্যাঁ স্যার, ওই মানে ঘরে দেখার সময় একটু ডাউট হলো আর।
হ্যাঁ হ্যাঁ বলো।
হ্যাঁ স্যার, এই 3 নাম্বার যে কোশ্চেনটা,
নাম্বার 3 কোশ্চেন, হ্যাঁ এইটা, হ্যাঁ বলো।
হ্যাঁ এখানে কারেন্টের থার্ড লুপে I3 কারেন্টের ডিরেকশনটা তো ক্লকওয়াইজ, কিন্তু বিটা এর যে ভোল্টেজ সোর্সটা আছে, ডিপেন্ডেন্ট ভোল্টেজ সোর্সটা আছে, সেটা তো ক্লকওয়াইজ দিকে কারেন্ট মানে পাঠাচ্ছে, কিন্তু সেটা মাইনাস বিটা আই হলো কেন? এটা তো প্লাস বিটা আই হওয়ার কথা।
কোনটা? এইটা?
হ্যাঁ এই ডিপেন্ডেন্ট ভোল্টেজ সোর্সটা।
তাহলে R3 I3 ওকে প্লাস 1/c ইন্টিগ্রেশন অফ I3 dt ওকে,
বাকিটা ঠিক আছে কোনো অসুবিধা।
হ্যাঁ ওকে, প্লাস R2 I3
বিটা আই এর সাইনটা নিয়ে করো।
এই অবধি যখন তুমি লিখেছো তখন তুমি কোথায় আছো? তখন তুমি এই জায়গাতে আছো, তাই তো? You have started to write equation from here. This drop you have written, this drop you have written, this drop also you have written. এখানে কি হলো? ভোল্টেজ ড্রপ হলো, কেননা in the direction of current there is drop in voltage, in the direction of current there is drop in voltage, in the direction of current there is drop in voltage. All right, কিন্তু যখন এখান থেকে তুমি এখানে যাবে, is there a drop in potential or a rise in potential? বুঝতে পেরেছো?
কারেন্ট তো হাই ভোল্টেজ থেকে লো, মানে হাই ভোল্টেজ সাইড থেকে লো ভোল্টেজ সাইডের দিকে ফ্লো করবে, কিন্তু তুমি এখানে আর তো কারেন্ট নয়, এটা একটা সোর্স। এই সোর্সের নেগেটিভ টু পজিটিভ টার্মিনালে যখন তুমি মুভ করছো, ইউ আর বেসিক্যালি মুভিং ফ্রম এ লোয়ার পোটেনশিয়াল টু এ হায়ার পোটেনশিয়াল। আমি যখন R3 অ্যাক্রসে মুভ করলাম, তখন আমি মুভ করছিলাম ফ্রম হায়ার টু লোয়ার পোটেনশিয়াল। হায়ার টু লোয়ার পোটেনশিয়াল মুভ করে যদি আমি পজিটিভ বলি, লোয়ার টু হায়ার পোটেনশিয়াল মুভ করাটা হবে নেগেটিভ। Okay, here there is a drop in voltage considered to be positive. Rising voltage in this case obviously will be negative voltage. Okay, drop ko jodi positive boli, rise ke to negative bolte hobe. Is it clear? Okay sir,
okay. Now come here, you tell me whether in this example, is it clear to all of you? This one 21.5 explanation of this figure 21.5 and calculation of Thevenin. Is it clear to all of you?
Yes sir.
Okay, then next step is to find out the Thevenin impedance. Okay, actually you should be able to do this Thevenin voltage determination, that is already known to you, that is nothing new, but determination of Thevenin voltage is somewhat new because previously in the previous semester whatever you have done, you have simply manipulated the impedances. Parallel combination of impedance, series combination of impedance, star delta conversion, and like these things you have done. Now here we shall have to measure the impedance. How? As a ratio of voltage and current. Why you have to measure the impedance here, particularly in this case? Because we have some dependent source. And Thevenin impedance or Norton impedance, whatever may be the impedance you will be calculating or you will be determining, that has to be done by removing the independent source but retaining the dependent source in the circuit. That means dependent source must be allowed to operate. এদেরকে allow করতে হবে, operate করতে দিতে হবে। কিন্তু independent সোর্সটাকে আমরা রিমুভ করলাম। Here V1 is not shown. V1 is removed. Internal impedance of V1 as if it is 0, so it is shorted this time. Okay, so this external resistance, 1 ohm resistance is there. V1 has been removed, it has been shorted. Okay, the independent source has been removed. But what will happen along with the removal of this source? This source AV1 আমাদের এটাকে রাখা উচিত, because the Thevenin impedance must be calculated with the control source or dependent source kept in the circuit. এটাকে আমরা রাখারই চেষ্টা করব, কিন্তু রাখতে পারছি কিনা দেখা যাক। AV1 is the voltage here. A is a constant. V1 is the this voltage. This is the dependent voltage. So you must remove this independent voltage. You must remove this independent voltage. কাজে এটা যখন আমি remove করছি, V1 is becoming 0 here. So you cannot retain V1 in this circuit. Means since this is an independent voltage source, along with the removal of this independent source, this voltage, dependent voltage source also will be removed from here, because we cannot maintain it. Because V1 has to be made equal to 0. As V1 becomes 0, this source also becomes 0. Okay, so these two resistances are there. Is it clear why AV1 is not here, but BI1 is here? BI1 is here because you see that I1 is the current through this branch. Whatever may be the value of I1, it will produce a voltage equal to B times of that current here. Whatever may be the value of this current, a voltage B times of this current will be produced here. And this B times of I1 is here, shown here. This resistance is here. Now you have to energize this voltage source. Energize this voltage source. It must be activated. To make it activated, to make it active, I have to arrange to flow some current I1 through this branch. Through this branch I1 must flow. Okay, তাহলে কি করতে হবে? There is a dependent source. It cannot drive any current unless there is a independent voltage source. There is an independent voltage source, because that independent voltage source will basically drive a current I1 through this branch. Then only this BI1 will be produced here. So to produce current I1 to this branch,
স্যার,
হ্যাঁ বলো।
সৌম্যদীপ বলে একজন বোধহয় ঢুকতে পারছে না, একটু দেখুন।
Okay. All right. করা উচিত। Okay. কি হচ্ছে এবার দেখো, is it clear that এখানে আমরা BI1 is the dependent voltage source. Okay. I1 is the current through this branch. তার মানে whenever you are finding the impedance here, since this impedance will be dependent upon this voltage source here, this voltage source must be activated, and it will be activated by this current I1, which is this branch current. তাহলে I1 ফ্লো করতে গেলে একটা সোর্স দরকার, সেজন্য আমরা এখানে সোর্স লাগালাম। সোর্সটা এখানেই লাগাচ্ছি কেন? কারণ এখানে লাগালে পরে if the source is connected here, what I can do, I can calculate the current delivered by this source, and if I know that current, then this voltage divided by current will be the impedance seen by the source, and that impedance is the Thevenin voltage. Thevenin impedance, sorry. Okay, that means the impedance seen by this voltage source will be the impedance available between these two terminals, and that is the Thevenin impedance. That's why voltage source is being connected here. Am I clear?
Yes.
Could everyone understand why you are connecting a voltage source? Because unless you connect a voltage source, you cannot arrange to produce a current I1 through this branch. Because BI1, this cannot drive any current. When current I1 flows here, then only a voltage will be produced, then it can drive some current. Okay, তার আগে পারছে না. So first of all, some current must flow through this branch. To make this current flow through this branch, we have to connect a source here, and that source is say V. So I determine V, I determine the current delivered by this source, then V by I will be the Thevenin impedance. Okay. Now once you do this, now you calculate the voltage.
স্যার ওই ডিপেন্ডেন্ট সোর্স AV1 ওটা কেন ইনক্লুড করা হলো না ওটার উপর বলবেন?
AV1 is a dependent source, but dependent on whom? Dependent on this voltage source, V1. V1 is an independent voltage source. তাহলে to determine the Thevenin impedance, we have to remove this independent source. এটাকে রাখা যাবে না. তাহলে এটা যে এই মুহূর্তে আমি রাখবো না, what will be the value of V1? That will be equal to 0. Is it clear? When I remove this means these two terminals will be shorted. So what is the voltage available between these two terminals? It will be 0. As this is 0, AV1 is also 0. Is it clear? Because independent source must be removed. How? It will be removed, but its internal impedance will be left in the circuit. What is the internal impedance? Nothing is given here. So since nothing is given, we can assume that internal impedance is 0. কারণ কি voltage source বলতে আমরা বোঝাই, we are assuming that as if this is a constant voltage source, and constant voltage source, a voltage source having 0 impedance. That's why you are assuming this to be 0. Okay. When it is impedance is 0, so when it is impedance is 0 means you have to make those two terminals shorted. What will be the voltage measured between these two terminals? It will be 0. So when V1 is 0, obviously V1 also will be 0. That's why this is not shown here. This is also not shown here. Is it clear?
Yes, sir.
Any confusion, anybody?
স্যার বলছি V1 এর যদি ইন্টারনাল ইম্পিডেন্স থাকে তখনও কি সেম হবে, মানে AV1 টাকে রিমুভ করতে পারবো তখন?
তখনও AV1 ইউজ করতে পারবো, বিকজ ইন্টারনাল ইম্পিডেন্সের বাইরে যেটুকু সোর্স সেটুকুই তো সোর্স, আর যেটুকু ভোল্টেজ সেটাই তো ভোল্টেজ সোর্স। ওকে,
আচ্ছা,
অলরাইট। অর্থাৎ V1 সরিয়ে ফেলেছি, মানে V1 is 0 means AV1 is also 0. Okay, because this is a dependent voltage source, but it is dependent on an independent voltage source. So since independent voltage source has to be made 0, this dependent voltage source here is also becoming 0. Okay. All right.
Yes.
Okay. Now remaining portion is very simple now, because you now calculate the Thevenin impedance here. How? You calculate the current delivered by this source. How to calculate this? You can write a loop equation here. Okay, either you write a loop equation for this loop or write a loop equation for this loop. Whatever equation you write, obviously you will be able to calculate the current. What we have done here, V equal, say current, this I1 actually will be flowing in this direction. Here the current is I1. Is anybody trying to join or no? I don't know. Oh, yes. You see that if this is current I1, what is the impedance here? 1 ohm. So after removal of this source and this source, impedance here is also 1 ohm. So you said these two branches are identical branches now. Am I clear? Here 1 ohm resistance, here also 1 ohm resistance. So if current I1 flows through this branch, current I1 will also flow through this branch. Why? Because these two impedances are in parallel. Is the logic clear? You see that through this impedance or through this 1 ohm resistance, current flowing is say I1. It is given, because if this is I1, then VI1 will be here. So if I assume that I1 is flowing through this branch, what will be the current flowing through this branch? That also will be I1, because these two impedances are identical. They are connected in parallel. So if I1 flows here, I1 will also flow here. So I1 here, I1 here. In this direction, what will be the current? Current will be 2I1. So we can say that through this 1 ohm resistance, current will be 2I1. Okay, that means through this source, current will be 2I1. Am I clear?
Sir,
Alright.
sir, instead of a V1, if the dependent source is a I1, then we cannot remove
Then we
the.
cannot. Then it will be activated here. If it is instead of a V1, if it becomes a I1, obviously then you have to keep it here. Okay.
Okay, sir. Okay, sir.
Okay. So if this is I1 and this is I1, then through this branch, what will be the current? It will be 2I1. Okay. It will be 2I1. So it will be 2I1. If it is 2I1, you can write the equation V equal to minus I1. That means through this branch, drop is minus I1 plus BI1 minus 2I1. So starting from here, you see that we are considering this drop, 2I1 flowing in this direction. So drop will be 2I1 into 1. Here it is BI1. So negative to positive terminal, it is BI1. So it is, we are moving in this direction, rising potential BI1. Then in this direction, from this terminal to this terminal, 2I1 is the current. So minus 2I1 is the drop. And here, from here to here, I1 is the current. So drop in potential, minus I1 is the drop. So this, okay, then it will be equal to, this V will be equal to ultimately across this voltage, this is the total drop. So this is the expression. Now you find out the value of V by 2I1 we are writing. What is V by 2I1? Why 2I1? Because you see through this branch current is 2I1 and that is in this direction. That is how much is the current delivered by the battery, delivered by the source here. This current 2I1 is entering through this terminal, but actually this source will deliver a current in the opposite direction. So current is actually equal to V, current is actually equal to minus 2I1 because 2I1 is moving in this direction, flowing in this direction. Actually current delivered by the source will be minus 2I1. So V by minus 2I1 is the impedance seen by the source. So V by minus 2I1 means V by I1 with the minus sign, it will be 3 minus V by 2, and that is the Thevenin voltage. Is it clear? You see, there is a simple trick. What is the trick? Because we have avoided writing more equations by simply considering that, simply by observation, we can say that if current I1 flows here, current I1 also will flow here. Okay, that's why we have written this current to be I1 and completed this equation here, found out the voltage, expression applied KVL here, then V by minus 2I1 is the impedance. Okay, that is 3 minus V by 2, and this is the Thevenin voltage. Is it clear?
Excuse me, sir.
Remember?
Sir, you told that there is current, equal current in both the resistance. Like if the resistance are equal, then only the
Then
in
only you
both
can
the
write. Actually, what happens? Because you have to actually in circuit theory, you can apply some general theorem. Okay, but from circuit to circuit, depending upon the nature of the circuit, depending on the particular situation, you can apply some special trick. This trick has been applied here. Obviously, if the impedance is somewhat less, we could write the expression. Say it is I1. Say it is 2. What would have been written here in that case? What I could write? Since it is 1 ohm, it is 1 ohm. We have written I1 here, I1 here. Say this is 1 ohm, but this is 2 ohm. Then what we can write?
like the first one will be 2I1 by 3 and this one will be I1 by 3.
Say this is I1. Okay.
I1 by 2.
I1 by 2. Because 1 ohm is the resistance here. Through this current flowing is I1. So here, if the resistance is 2 ohm, obviously current will be half. Why half? Because voltage is same across the two branches. Okay. So same voltage will deliver more current to the lower impedance. How much more? This impedance is say half of this impedance. Okay, that means current here will be twice of this current. That's why if I1 flows here, Here it will be I1 by 2 if resistance is 2 ohm. Okay, so in this way, for this particular case, you can actually find out the value of this current in terms of this current, and you can simplify the analysis. Am I clear?
ওপরে স্যার এখানে যে ভিটিএইচ এর যে ইকুয়েশনটা লেখা আছে ওটা এভি ওয়ানটা এলো কিভাবে? মানে মানে এই দুটো ব্রাঞ্চে তো ওই সেম কারেন্ট তো আমরা করতে পারছি না, না তো এখানে
না না
এভি
না, আসছে নি। এখানে কি হচ্ছে, ইউ আর রাইটিং দ্য ফাইন্ডিং অফ দ্য ভোল্টেজ অ্যাক্রস দিস টু টার্মিনালস, তাই তো? কি করতে পারো, ইউ ক্যান ফাইন্ড আউট দিস ভোল্টেজ, দেন দিস
ইয়েস স্যার,
ভোল্টেজ, or you
ইয়েস
can
স্যার,
find out this voltage and this voltage. আমরা কি
ইয়েস
করেছি,
স্যার।
আমরা এই ভোল্টেজটা বার করেছি, তার সঙ্গে এটাকে অ্যাড করেছি। আমরা এটাও করতে পারতাম, এই ভোল্টেজটা বার করতে পারতাম।
হ্যাঁ, তো মানে হচ্ছে এখানে তাহলে হচ্ছে মানে হচ্ছে আই ওয়ানটা তাহলে এটা আসছে কিভাবে? মানে আমরা যদি এই দিকের ব্রাঞ্চটা যদি নিচ্ছি, সো এখানে যে ভিটিএইচ এর ইকুয়েশনে এভি ওয়ান প্লাস এই আই ওয়ানটা এখানে আসছে কি?
যখন when you are writing the expression for V Thevenin, obviously these two terminals are open. Okay, if the terminals are open, what will be the current flowing through this branch? Zero current. That means
জিরো, আচ্ছা আচ্ছা,
this
মানে যে
I1
আই ওয়ানটা ওটা দিয়ে ফ্লো
downward,
করবে। হ্যাঁ,
এখানেই ফ্লো করবে, ডাউনওয়ার্ড ফ্লো করবে, তাই তো?
ওকে ওকে,
ইজ ইট ক্লিয়ার? এখানে হলে তুমি কি লিখতে, এখানে
ইয়েস
হলে
স্যার, ইয়েস
লিখতে
স্যার।
V1
এখানে
plus I1 into 1 plus BI1, তাই লিখতে,
ইয়েস
তাই
স্যার।
তো? Alright, is it clear? Now
Yes, sir.
anybody else, any question regarding this Thevenin impedance particularly? I think you could understand this one. Now is it clear? The second part, that means figure 21.6, where the Thevenin impedance has been explained and it has been found out. Is it clear to you or not? Anybody? Everyone please check whether it is clear to you or not, because things are very simple, but you must understand that. You must be able to
Sir, স্যার বলছি I1 এর যে এক্সপ্রেশনটা বার করেছেন V1 মাইনাস AB1 বাই 2, ওটা কি দুটো 1 ওহম যে দুটো প্যারালাল আছে, ওটা কি দুটোকে কি ইকুইভ্যালেন্ট রেজিস্ট্যান্স পার করে করা হয়? মানে ওটা কিভাবে হলো?
না না না, কি হবে, এটা যখন তোমার ওপেন রইলো তখন এটা একটা ক্লোজ পাথ, তো এটা তো একটা লুপ ফর্ম করছে।
হ্যাঁ হ্যাঁ,
it is forming a loop. So in this loop you write the voltage equation, তাই তো? In this volt you apply KVL. What is the
আচ্ছা
KVL?
ওটা করলেই তাহলে I1টা বেরিয়ে যাবে, ঠিক আছে।
তাই বেরোবে, তাই না? আমরা করলাম কি, এই লুপের রেজাল্টেন্ট ভোল্টেজ কত, লুপের রেজাল্টেন্ট ভোল্টেজ হচ্ছে V1 মাইনাস AB1, লুপের ইম্পিডেন্স কত 1 প্লাস 1 2, সরাসরি V1 মাইনাস AB1 বাই 2 করে কারেন্টটা বার করলাম। Or you can,
ওকে স্যার।
okay, any more question, anybody, any doubt? Whatever may be the question, whatever may be the doubt, you please ask me. Okay, কারণ এখানে ফাঁকা থাকলে পরে মুশকিল হয়ে পড়বে। So try to make it clear here. Things are simple, but these simple things must be clear to you. Any no question, I think, anymore? আর কেউ কোনো কোশ্চেন করবে?
হ্যালো স্যার।
হ্যাঁ বলো।
হ্যাঁ স্যার, বলছি যে এই যে সেকেন্ডের যে ব্রাঞ্চটা সেটা আর ওই BI1 ওটা দুটো মিলিয়ে VTH টা ধরেছে, আমি সাইডের ব্রাঞ্চটা ধরতে পারবো?
এটা 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 ধরতে পারবো কিনা, তাই তো?
হ্যাঁ হ্যাঁ।
So let us do it. Okay, this calculation is shown considering this branch and this voltage. Let us calculate the Thevenin voltage considering this branch and this one. Then what will be? তোমার কাছে খাতা পেন্সিল একটা কেউ লিখবে, তাহলে সুবিধা হবে বলতে। It will be V1. Rise in voltage is V1. Okay, starting from here, আমরা এখান থেকে এখানে এলাম, তো V1 plus rise in voltageটা যদি পজিটিভ লিখি, মাইনাস এটা কি হবে, ইন দ্য ডিরেকশন অফ কারেন্ট ফ্লো করছি, দেন মাইনাস I1 ইন্টু 1 মানে কত, V1 মাইনাস AB1 বাই 2, দেন মাইনাস B, এখানে প্লাস হবে আবার, প্লাস BI1। ওকে, তাহলে এখানের বেলায় কি হবে, এখানের বেলায় হচ্ছে AB1 প্লাস এই কারেন্টটা হয়েছে, কেন হয়েছে, কারণটা ফ্লো ইন দ্য অপোজিট ডিরেকশন। এখানের বেলায় কি হবে, V1 প্লাস sorry, V1 minus this current. So if it is V1 minus AV1 by 2, what is the resultant? You see, ultimately you will get this voltage. You can do
Okay,
it.
okay, sir. Okay, sir. Yes, sir.
There
Yes,
is
sir.
nothing. Okay.
Yes, sir. Yes.
Alright, clear. Achha. Now any further question? Anybody? Figure 21.6 for Thevenin impedance calculation. Anybody? Any question? Okay. If no further question, then we can, for the same circuit, we have shown the determination of Norton current as well. Say we are discussing Thevenin equivalent and Norton equivalent together because they are similar, dual of other. Okay, you can say that in Thevenin's theorem, we actually represent a circuit between its two terminal by a voltage source and series impedance. Using Norton's theorem, what we can do, we can represent the same circuit using a current source with parallel impedance. Okay, impedance value is same. Thevenin impedance and Norton impedance both are same. So now let us apply Norton's theorem across this circuit, across these two terminals. Okay, and let us find out the Norton current. So if you find out the Norton current, what you have to do? You have to put an ammeter between these two terminals. Right? So you will calculate the current between these two terminals. So short circuit these two terminals. Like this, short circuit the terminals. All right. This circuit was previously like this. This was a voltage source. This is a dependent voltage source, and this is dependent voltage source. Now this has been written in this form. That means here we have performed some equivalencing has been done here. Okay, so you see whether it is clear or not. Between that means with the resultant, that means these two has been considered and represented in this fashion. V1 by 2, then plus a V1 by 2, then minus. That means this portion remains as before. Okay, but this portion has been shown by an equivalent circuit because we shall find out the Norton current. Okay, you can actually calculate this current, write a loop equation here, or what has been done here by using source conversion, we have converted the circuit in this form. Now, is this conversion clear to you or not? Is this conversion clear to you or not? You see that this is a voltage source. We can convert it into a current source. Okay. So V1 by 2 is the V1 by 1. That is the current source with parallel impedance 1. A V1 by 1 is the current source with parallel impedance 1. Now resultant current source is V1 plus a V1. Resultant impedance is half. So again, this resultant current source, that means V1 plus a V1 by 2, has to be multiplied by half to convert into voltage source. Resultant voltage source will be V1 plus a V1 into half. That means V1 plus a V1 by 2. Okay, that means V1 by 2 plus a V1 by 2, and in series impedance will be half. That has been done here. That means two voltage sources first have been converted into current sources, added up, and then again converted into voltage sources. Finally, this configuration, this type of this equivalent has been found out, and now with the external part of the circuit, this is the total circuit. Now you put a short circuit here. Now it is very simple. A voltage source, all are connected in series. So it will be AV1 plus V1, AV1 by 2, V1 by 2 plus BI1 divided by this half. Okay, so it will be the Norton current. All right.
স্যার বলছি যে এখানে I1 টা আর ওই আগের I1 টা দুটো তো সেম হবে না,
আগে I1 টা কি হবে?
কারণ আগের I1 টা যখন বার করছিলাম তো ধরে নিয়েছিলাম ওই জায়গাটা ওপেন সার্কিট হয়ে গেছে, ওখানে কারেন্ট ফ্লো করছে না। বাট এখানে তো আমরা ওই I1 ধরেই ক্যালকুলেট করে দিলাম।
হ্যাঁ, না তোমাকে দেখতে হবে যে আমরা যখন ইকুইভ্যালেন্ট করেছি এটা তো ওপেন সার্কিট কন্ডিশনে ছিল। এই অবস্থায় I1 টা কোনটা সেটাই থাকবে, এখানে আর কিছু হচ্ছে না। ঠিক আছে, আমরা তো এটাকে ইকুইভ্যালেন্ট করলাম, তারপর শর্ট করব। যখন আমি ইকুইভ্যালেন্ট করছি এটাকে, the same I1 will actually be flowing here. So I find the value of I1 from here. Because আমি যদি এটাকে কনভার্ট করি, এই I1 টাকে লাগাতে হয়, এখানে ইউজ করতে হয়, then I1 must be equal to the current flowing through this branch when the branch is connected in this way. If I now use the source conversion technique, then what will happen? Obviously the configuration of this branch will change, তাই তো? এটা চেঞ্জ করে গেছে, উল্টো কিছু হয়ে গেছে, কিন্তু তাহলে আমি I1 টাকে এখানে পাচ্ছি না তো, but some value of I1 has been used. তাহলে কোন ভ্যালুটা ইউজ করব? It will be the value of I1 when the circuit was in this configuration. এখানে যে
এইটা নিয়ে প্রবলেম নেই, বাট এখানে যখন আমরা I1 বার করেছিলাম তখন তো আমার টার্মিনাল পুরো ওপেন সার্কিটেড ছিল।
হ্যাঁ,
বাট যখন আমি নট
আমরা কি করতাম না, এবার আমি যখন করছি, আমি ওপেন সার্কিট কন্ডিশনে এটাকে একটা ইকুইভ্যালেন্ট সার্কিটে কনভার্ট করে নিচ্ছি, ঠিক আছে? করে নিয়ে এইবার আমি সেখানে একটা শর্ট করছি সিম্পলি, তাহলে সেই কারেন্টটা বার করব। I am first converting this source, this total circuit in a suitable form, যাতে করে আমি নর্টন কারেন্টটা ইজিলি বার করতে পারি। So that's why this conversion has been made. Okay? Otherwise তুমি অন্যভাবেও করতে পারো। তুমি কি করতে পারো? You now put the short circuit here, write a loop equation, write one loop equation here, one loop equation here, so two equations will be obtained, then find out this short circuit current, no problem. অর্থাৎ তুমি এইভাবেও দুখানা ইকুয়েশন লিখে সলভ করতে পারো, অর এইভাবে সোর্স ট্রান্সফরমেশন ইউজ করে এটা অন্যভাবে করতে পারো আর কি। এখানে ওই স্টেপটা দেখানো হয়েছে। সিন্স সোর্স কনভার্সন হ্যাজ বিন অ্যাকচুয়ালি ডিসকাসড, আমরা এখানে সোর্স কনভার্সন করে করলাম। তোমরা যে কটা করতে পারো, ইউ মে অ্যাভয়েড দিস, রাদার হোয়াট ইউ ক্যান ডু, you can put the short circuit here, write a loop equation, write another loop equation, two loop equations will be written. Now in terms of this, from these two equations you can find out what is the current flowing through this short circuit. That also can be done. Okay, এটা করলে
ডাইরেক্ট ম্যাট্রিক্স প্রসেস অ্যাপ্লাই করে তো বার করা যাবে I1 এর ভ্যালুটা।
হ্যাঁ, সেটাও করতে পারো। সিম্পলি তুমি দুখানা করে ম্যাট্রিক্স লিখো, কিন্তু ওই ডিপেন্ডেন্ট সোর্সগুলোর ভ্যালুটা ঠিকঠাক লিখতে হবে। ক্লিয়ার? হ্যাঁ, বলো।
আমি বলছি যে আমি ধরুন টার্মিনালসটাকে আগে শর্ট সার্কিট করে দিলাম, মানে যেই টার্মিনালে এই থেভেনিন ভোল্টেজ বার করেছে ওই দুটো টার্মিনাল আমি শর্ট সার্কিট করে দিলাম। হ্যাঁ, করে আমি I1 এর একটা ভ্যালু বার করলাম, তারপর আমি সোর্স কনভার্সন করলাম।
তারপর মানে এটা দিয়ে বার করতে পারলে তো আর তোমার আর দরকার নেই। এটা কি ছিল, এখানে I1, এখানে I1 রয়েছে, তো এইবার এই সার্কিটে তোমার এই ভ্যালুটা বার করতে হবে। ওকে, এখানে তুমি কি করছো? শর্ট করছো। এই শর্ট করা অবস্থায় যদি তুমি I1, কারণ এখানে কোনো চেঞ্জ হয়নি, এখানে চেঞ্জ হয়নি, এখানে যাই I1 বেরোবে সেটাই তুমি এখানে বসাবে, কোনো প্রবলেম নেই। বুঝতে পারছো? যতক্ষণ না তুমি এটাকে চেঞ্জ করছো ততক্ষণ কিন্তু যা ভ্যালু পাচ্ছ দ্যাট উইল বি producing a voltage here, B times I1. Okay, তুমি কি করতে পারো? You will short circuit this and find out the value of I1. তখন I1 টা বার করাটা সহজ হবে না। কেন সহজ হবে না? Because this loop is closed. When this loop is closed, obviously again a current will be flowing because of this source here. খুলে গেছে, কাজে ওইভাবে আমরা যেভাবে এখন সরাসরি কারেন্ট বার করছি ওইটা কিন্তু আর সরাসরি বার করতে পারবে না। The value of current will change then. Am I clear? কেন চেঞ্জ হবে? বিকজ সেকেন্ড পাথ ইজ ক্রিয়েটেড। এখানে লিখতে পাচ্ছি কেন? there is no other path, সেই জন্য লিখতে পাচ্ছি। আর কোনো কারেন্ট ফ্লো করছে না, কাজে সরাসরি obvious what will be the current flow. But as soon as you close this, obviously the current I1 cannot be determined directly here, because in that case you don't know what is the voltage here. এই ভোল্টেজটা জানলে পরে তখন কারেন্ট I1 টা বার করতে পারবে। This voltage here will depend upon the current that will be flowing here, because that current will produce a drop here also. বুঝতে পারলে তো? কাজে কি হবে? কাজে ওইটা করতে গেলে একটু স্টেপ বেশি লাগবে, অবশ্যই করতে পারবে, কিন্তু হবে কি, rather a somewhat lengthy process, a little lengthy process will be there. এখানে যেটা করা হয়েছে, to avoid that lengthy process, shortcut has been applied. And what is a shortcut? You convert one type of source to another. The simple step that we have discussed already, that has been applied here. সেজন্য এরকম করা হয়েছে। But you need not stick to this method. You may rather put a short circuit here, write loop equation, and the value of I1 you put here depending upon the value of I1 here, and then solve, you will get the Norton current, no problem. Okay, whatever may be the method that is appearing to be simple to you, you can apply that, but try to understand, try to learn all the methods. Okay, is it clear?
Yes, sir, clear.
Anybody else, any other question? These are simple things, simple questions, কিন্তু tricky question গুলো ভালো. So you please ask me question. Anybody, those যারা চুপ করে রয়েছো, those who are not making any questions, please think and make question, because that is necessary, particularly in this form of teaching, যেখানে আমি তোমাদের দেখতে পাচ্ছি না, তুমি সরাসরি আমাদের দেখতে পাচ্ছ না, বোর্ড করে যাচ্ছে না, বলো
স্যার।
ওকে, প্লিজ বলো।
স্যার বলছি যে এখানে যে আই নর্টনটা বেরোলো, আর আগে যে আমার থেভেনিন ভোল্টেজ বেরিয়েছিল, দুটো যদি ডিভাইড করে যে ইম্পিডেন্সটা বেরোবে, ওটা কি আগের সাথে সেম হবে?
আগের সাথে সেম হবে,
বাট স্যার হচ্ছে না তো। এখানে ডিভাইড করলে তো 3/2 বেরোচ্ছে, আর আগে আমার 3 মাইনাস b/2 বেরোচ্ছিল। এটা আমার বলছি, এটাই প্রবলেম।
কি হয়েছে এখন, কত হয়েছে?
এখন তো আমার আই নর্টন বেরোলো v1/3 আর 1 প্লাস a প্লাস b মাইনাস ab, আর আমার ভোল্টেজ অ্যাক্রস দ্য টার্মিনাল বেরিয়ে গেছে হচ্ছে হলো v1/2 আর 1 প্লাস a প্লাস b 1 প্লাস a প্লাস b মাইনাস ab। তো দুটো ডিভাইড করলে তো 3/2 আসছে ইম্পিডেন্সটা।
3/2 আসছে মানে ওই এবি থাকছে না, এবিও থাকছে
না, মানে নর্মাল থেভেনিন লাগিয়ে তো আমার 3 মাইনাস b/2 আসছিল।
হ্যাঁ হ্যাঁ,
বাট এখন যদি আমি কারেন্ট মানে ভোল্টেজটাকে কারেন্ট দিয়ে ডিভাইড করি, আমার তো 3/2 আসছে।
শুধু 3/2 আসছে?
হ্যাঁ, এটা আমি বলছি যে আমরা যখন ওই মানে I1টা ক্যালকুলেট করছি না, আমরা তো ওপেন সার্কিট I1টা ক্যালকুলেট করছি, তো সেটা তো হবে না। আমরা যখন নর্টন লাগাচ্ছি, আমরা তো ক্লোজ সার্কিট করে যে I1টা বেরোচ্ছে সেটা আমাকে লাগাতে হবে।
Okay, let me check it and then I shall tell you in the next class. আমি এটা করে দেখবো, করে বলবো। ওকে
ওকে,
এখানে কনফিউশন হচ্ছে, সো let us তো এটা করে রাখো, তাহলে নেক্সট ক্লাসে আমি এটা করে দেখছি, করে নেক্সট ক্লাসে তাহলে বলবো। ওকে
ওকে,
অলরাইট, হ্যাঁ বলো।
স্যার ফিগার 21.5 এর পাশে মানে VTH থেভেনিন ভোল্টেজটা ক্যালকুলেট করার সময় মাইনাস এবি টার্মটা করতে যায়।
মাইনাস VTH,
হ্যাঁ ওখানে সেকেন্ড লাইনে মাইনাস এবি টার্মটা
ওই I1 এর এক্সপ্রেশনটা দেখো, ওইখানে I1 এর এক্সপ্রেশনে ওটা ইনটু বি করলে এবি
করে।
I1 is
I1টাকে চেঞ্জ করে, হ্যাঁ ঠিক আছে।
I1 ঠিক আছে, আর আমরা তো এটা থেকে বার করেছি I1 is flowing downwards through this branch, তাই তো? I1 যদি ডাউনওয়ার্ডস ফ্লো করে তাহলে কি হবে, তুমি যখন এখান থেকে মুভ করছো মাইনাস টু প্লাস, এটাকে যদি আমি রাইজ ইন ভোল্টেজ B1 লিখছি, এইবার মাইনাস টু প্লাস মানে আবার রাইজ ইন ভোল্টেজ হচ্ছে, তাহলে I1 ইন্টু 1 প্লাস মাইনাস টু প্লাস মানে প্লাস BI1 ওকে, ক্লিয়ার? ঠিক আছে এটা, ওকে আচ্ছা, এটা আমি তাহলে দেখছি, ক্যালকুলেট করে দেখে বলবো নেক্সট ক্লাসে। নাও consider another example here. It is very simple. Now the difference is that here a coupled elements are considered, then how to find out the impedance when you are having inductively coupled circuit. Okay, তাহলে এখানে একটা সার্কিট রয়েছে, two inductors which are mutually coupled, value দিয়ে রয়েছে। So 1 volt is a sinusoidal source with instantaneous positive polarity here, instantaneous negative polarity here. Impedances are J5 ohm self impedance, J5 ohm self impedance, আর এই দুখানা ইন্ডাক্টরের মধ্যে J3 is the mutual impedance. Okay, J3 is the mutual impedance. Now you have to find out the Thevenin voltage, means voltage available between these two. So what you can do, you already have done that. If there is mutual coupling, we can draw the equivalent circuit like this. Okay, how to draw the equivalent circuit? Current I1 we are considering to solve using loop current technique. Current I1 is entering through this branch, is flowing through this loop. Current I2 through this loop, through this drop, through this dot, I1 is entering through this dot, I2 is also entering. So Here self-induced EMF and mutually induced EMF will assist each other. Here also self and mutual will assist each other. তাহলে কি হবে? J5 is the self-inductance. Now when I1 flows in this direction, here will be the I1 flowing in this direction. Obviously there will be a opposing EMF induced, self-induced EMF will have positive polarity here, negative polarity here. Okay, because current is entering through this terminal, higher potential, leaving through this terminal, lower potential. So plus here, minus here. To assist this, the mutually induced EMF also will have plus here, minus here, and the value will be J3I2. J3I2. Similarly, for this inductor, J5I2 is the mutually induced EMF here. Okay, with a positive polarity here, negative here, because I2 is the direction of current. Now, this current actually then what will happen? Because of this current flowing here, an EMF will be induced, and that will be in the additive mode. So plus minus here, value will be J3I1. Okay, so once you know the source here, this source here, this source here, now you write loop equation. In matrix vector form. This is the equation written. Now once this equation is written, you can find out this current I2. Now, okay, so you can easily do this. You know how to write the equation, you can how to solve the equation, you also know this. So if I2 is determined, then voltage across these two terminals AB will be the drop from here to here, because no current is flowing through this branch. It is open, means voltage drop across 4 ohm resistance. That means 4I2 will be the Thevenin voltage. 4I2 will be the Thevenin voltage. If the calculation is correct, then this will be the value 0.213 at an angle of minus 137.8 degree. Okay, is it clear?
Yes, sir.
Okay. Similarly, the finding out the impedance. For finding out the impedance, again the same process, somewhat lengthy process. Now to find out the Thevenin impedance, you remove this source. 1 volt source has to be removed. Okay, and it is shorted here. Source has been removed, but dependent sources are due to mutually induced EMF, so they are kept here. So this is due to mutual induction. This is due to mutual induction. Okay, these sources are here, but you must arrange the current to flow through these inductors. Otherwise, these EMFs will not be induced. So an independent source is required. So here, where the Thevenin impedance we measure, there you connect a voltage source of say 1 volt, say at an angle of 0. Assume that voltage to be the reference phasor for measurement. Okay, so what this 1 volt at an angle of 0 is delivering current to the circuit at its terminal, that you have to determine. So connect the voltage source here, see how much is the current delivered by this source. For that, now you have 1, 2, 3 loops. Okay, as before, you write current loop equation for the first loop, for the second loop, and for the third loop. Using this form, you can write the equation. Okay, and you can find out the current I3 very simply. It will be laborious process, but process is not difficult. So you can find out the current I3. Now, impedance seen by the source will be this voltage divided by the current delivered. I3 is in this direction, so impedance will be this voltage by minus I3. This voltage 1 at an angle 0 divided by minus I3 will be the impedance, and that will be 6.74 at an angle of 8.5 degree. Okay, is it clear? The process is lengthy somewhat. You have to calculate, you have to write the equation. Okay, but the method is simple. This is not difficult. Already this type of equations we have discussed. So it will take time for solving, because 3 equations, the 3 by 3 matrix, you take the determinant, divide, the current will be determined by, and impedance will be this voltage divided by the current delivered, which is minus I3. This has to be understood. what has to be, what I want to show here, basically all other thing you can do. It will be this voltage divided by the current delivered. What is the current delivered? It is I3, but direction is opposite to I3. Magnitude is I3, direction is reverse of I3. So it is this voltage divided by minus I3. That is this impedance. Okay? Is it clear? Any question, anybody?
No, sir.
Okay. So you can follow this. Now again another circuit is shown. This circuit you can better you go through this circuit, try to understand, then we shall explain. It is also very simple. What is shown here, here actually, because the page was broken here. Now this is the circuit. Here, this is a circuit with resistance say R1 and capacitor C2 in series. These two terminals X and Y. Across these two terminals, within these two terminals, we shall have to find out the equivalent, Thevenin equivalent. Say, when this switch here is closed, so let us assume that this source is closed at time t equal to 0. When this source is closed, this capacitor C1, okay, with capacitance C1, was charged as voltage V0 with positive polarity here, negative polarity here. So this circuit is having no other source excepting this initial condition. That means source due to initial condition is here. Okay. Source due to initial condition is here. And source due to initial condition has to be determined as an independent source. Okay. Now what you can show is that when this is closed, then now you can represent this. All right. Here when the transform will be necessary, and transform has not been done yet for you. So this analysis I should keep it pending now because this was not done for you. Okay. So when we discuss initial conditions later on, then we shall discuss this circuit, because we are not in a position to discuss this circuit. Laplace transform will be actually discussed in the other half. So after completing this, if the transform is completed, then I shall discuss it directly. If that is not done, I shall discuss Laplace transform briefly and then discuss this circuit along with the major initial conditions that we have skipped for the time being. Okay. So this circuit, this problem, we shall be discussing later on. Okay. After say 1 or 2 more classes. All right. So after Thevenin's and Norton's theorem, because I think now any other problem is given to you, you will be in a position to solve those circuit using Thevenin's and Norton's theorem. You can obtain the equivalent, Thevenin equivalent and Norton equivalent. And now let us consider the compensation theorem. This again is basically the application of Thevenin's theorem. Basically, it's called to be compensation theorem, but basically it's nothing but another application of Thevenin's theorem. Okay. So to analyze or to discuss this theorem, let us consider a very simple circuit now. First, say we have a voltage source and a series impedance. We may have been given a rather complicated circuit, but any circuit is given. If it is linear, okay, we can represent that circuit by its Thevenin equivalent. Then that means with the help of this Thevenin voltage and series impedance. Say this is the circuit whose Thevenin voltage and Thevenin impedance is known, and in this circuit we are connecting a load impedance of value ZL. Okay, so immediately you can find out the current, what is current is flowing through this circuit. Now we are basically interested in finding out the current that will flow through this branch when this impedance ZL is changed to ZL plus delta ZL. That means this branch impedance has been changed from ZL to ZL plus delta ZL. Its value has been changed. Value has been incremented. This delta ZL maybe have a positive value. delta ZL may have been negative, but that means we may increase the impedance, we may decrease the impedance. That means the impedance is changed. Under this change condition, we want to know what will be the current flowing. So this is the problem that has to be solved in this case. Okay. So what we can do to establish this method first? Let us first find out the current that will be flowing through this circuit when ZL is connected. When ZL is connected, what will be the current? V Thevenin is the voltage, Z Thevenin is the impedance, and ZL is the this branch impedance. So V Thevenin by ZL plus Z Thevenin will be the current. Now, say this impedance is changed to ZL plus ZL. Then what will be the current? Then it will be V Thevenin divided by Z Thevenin plus ZL plus delta ZL. V Thevenin divided by ZL plus delta ZL plus Z Thevenin. Okay. So this is the current. Very easily we can find it here because this is a very simple circuit. But compensation theorem we may be interested in applying in a circuit which is not so simple. We shall give that example. We shall not consider a very complicated circuit, but a circuit which is somewhat more complicated than this. Okay. Now, impedance is changed, then this is the current. Now, what is the change in current? Let us find it out. Change in current is delta I. Initially it was I, it became I1. So change in current from initial to final circuit is I1 minus I. I1 minus I, what is the value? That means this current minus this current. This may be found out to be this impedance multiplied by this impedance, then ZL plus delta ZL plus Z Thevenin minus ZL minus Z Thevenin. So ultimately this is minus V Thevenin delta ZL by this impedance. Okay, I can find out this current minus this current, and that comes out to be this. Delta I equal to this one. Now let us write it in a more simpler form. Delta I equal to minus of V Thevenin delta ZL by Z Thevenin plus ZL plus delta ZL into Z Thevenin plus ZL. So that may be written as I. That is the current that was flowing in the initial circuit, I. How write it I? It is V Thevenin by Z Thevenin plus delta L. This portion, this by this, we are writing I into delta ZL by Z Thevenin plus ZL plus delta ZL. So change in current is minus I. What is this I? It is the current that was flowing before the impedance was changed. That means this was the current flowing through this branch before the change in impedance. That we multiplied by change in impedance is delta ZL by total impedance of the circuit after the change in impedance. That means Z Thevenin plus ZL plus delta ZL. Okay, that we may write. So this is some voltage. I into delta ZL is some voltage. That voltage let us write VC, compensation voltage. Okay, so I delta ZL is a voltage. Since voltage by impedance is current, we write this product as a voltage and call that voltage as the compensation voltage VC. So VC is equal to I into delta ZL. I is the current that actually was flowing through this branch before the change in impedance, and delta ZL is the change in impedance. So compensation voltage is equal to current in the branch before the change in impedance into change in impedance is the compensation voltage divided by this impedance. Okay, so change in current equal to this thing, this expression. Now this expression delta I equal to minus VC by Z Thevenin plus ZL plus delta ZL, we can draw a circuit to represent this equation. We shall be drawing a circuit where this will be the current flowing, this will be the impedance, and this is the source. What is the circuit? This circuit will be like this. You see that we want to find the current, change in current through this branch. So there in this branch we are putting a compensation source VC. Okay, ZL plus delta ZL is the impedance of this branch after the change in impedance is the resultant impedance. We are showing the resultant impedance. Along with that, we are putting a compensation source. We are putting the source in such a way that you see that here it is minus VC. Why minus? Minus means here it was minus I into ZL. That means the change in current is in such a direction that the current that was flowing in the circuit initially will be opposed. That means polarity of the source therefore has to be placed in such a way that the current that was flowing through the circuit will be opposed. That's why a positive polarity here, negative polarity here. Okay. Now this is delta I that is equal to minus of this thing like this. So this expression delta I equal to minus of Vc by this impedance is being represented by this circuit, okay, where we have shown a voltage compensation source as if this compensation source is driving the current, okay. And what is this current? This current is actually flowing in this direction, okay, in this direction, and value of this source is I into delta ZL. Total impedance of the circuit is Z Thevenin here in the initial circuit shown in the original position. ZL plus delta ZL is the impedance, resultant impedance of the branch. So now we can find out the change in current from this circuit directly. Or you can say that to find out the current due to the change in the branch impedance, what we shall have to do? We shall have to put a compensation source in that branch where the impedance has been changed. Polarity of the source will be such that the direction of original current will be opposed. Magnitude of the source will be the magnitude of the current that was flowing through this branch initially into change in impedance. Okay, then this current delivered by the source will represent you the change in current in the circuit due in the branch because of the change in impedance. And when the change in current is known, we can find out the new current also. Okay, so this is said to be the compensation theorem. That means basically we are actually applying the Thevenin equivalent. Okay, why Thevenin equivalent? You see that source is compensation theorem, but the impedance where the current is being driven is a Thevenin impedance. Why it is Thevenin impedance? You see that here this impedance is kept intact. This Thevenin impedance. That means whatever may be the circuit, we shall not change that circuit any further. That means the circuit will be there. All the sources will be removed from the circuit except the impedances in their original position, and that is represented by a single impedance here, that is the Thevenin impedance. Okay, that means that if you have an elaborate circuit shown here, that circuit will remain intact and that will represent the Thevenin. Okay, so by using this source, using this theorem, we can find out the change in branch current due to the change in branch impedance using rather a shortcut technique. What is needed? We have to have a solution of the circuit before the change in branch impedance. Then a shortcut technique is possible to find out the new current in the circuit. Okay, now is it clear? Then we shall consider an example. Better rather we consider an example. Now this will be applied in this circuit. This is also a very simple thing. Simple circuit here. Okay, say this is the circuit. 1 volt source, then 1 ohm, here 4 ohm resistance, here 8 ohm resistance. This 4 ohm resistance is changed to a 2 ohm resistance. Now we shall have to find out the current due to this change in resistance in this branch. We shall be finding out the current here where the impedance has been changed. Using compensation theorem we shall do it. Okay, how to do it? First of all, you find out the current in the original branch. That current is I. That means what is the current flowing here? That you can find very easily because 1 volt source, then 1 plus here 4, 8 parallel, you can find out the total current. Okay, so you can find out the total current. So through this 4 ohm resistance, I will be total current is 1 plus 8 into 4 by 8 plus 4. Okay, and this is the total current, and out of this total current, now how much is flowing through this branch? They have to determine. Is it clear? You see that 8 by 12 is the total current. Okay, total current I, it will be, it is 1 volt by 1 plus 4 into 8 by 4 plus 8. That means it is 32 by 12. You find out the value, whether it is correct or not. Okay, then this current will be the original current. Is it 8 by 12? What is the original current? 8 by 12 of original current it will be actually. You see, calculate whether this is correct or not. Okay, therefore I, this current will be initial current into, this is the original current, 1 by 1 plus 4, 8 by 4 plus 8. This is the current I. Out of this current, how much will be flowing through this branch? It will be 8 by 8 plus 2, 4. So this is the current delivered by the source into 8 divided by 8 plus 12 will be the current I. So that is equal to 2 by 11 ampere. So we have determined this current. Now you find out the compensation source. In the compensation circuit, this is the compensation circuit. We shall remove the independent source that has been removed here. The 1 ohm resistance was here, it is kept here. 8 ohm resistance is here, it is kept here. Now in this branch, resistance has been changed. Here we shall put a compensation source. What is the magnitude? This I into delta Z. I is 2 by 11 ampere. Delta ZL. What is delta ZL? It is final impedance minus initial impedance. Initially it was 4, finally it is 2. So it is 2 minus 4. That means 2 minus 4. So ultimately VC will be equal to minus 4 by 11 volt. Minus 4 by 11 volt is the compensation source. So here the VC is placed with a positive sign here, negative sign here. Value is minus 4 by 11. Basically therefore is plus sign will be coming here, minus sign will be here. But we have followed the initial notation that here this term will be positive, this term will be negative. We have written the value as minus 4 by 11. Okay. Now, what is the current delivered by this source? Delta I is in this direction as if. Okay. You find out the current delivered by this source in this direction. So that current will be, current actually will be delivered by the circuit in the against the direction opposite to this. That's why it is a minus sign here. Minus voltage source value divided by impedance is 2 plus 1 into 8 by 1 plus 8. Okay. 2 plus 1 8 by 1 plus 8. So ultimately delta I is having this value. Okay. Ultimately it is again 10 by 11 into 3. The current in AV, if 4 ohm resistance is changed to 2 ohm, therefore will be I plus delta I. Okay. It is 2 plus by 11 plus 18 by 11 into 30. So this will be the resultant current using the compensation source. So what we have done here in the compensation source, we are not solving the total circuit again. Rather, using the initial solution, we are putting a compensation source here and finding out the current delivered by this compensation source through this impedance to find out the current in this branch of the circuit. Using this, we can find out the current everywhere in the circuit because this current actually will be distributed through all the branches. That distribution we can determine and find out the current in the new condition. So is it clear or not to you?
Sir, can you explain the direction of current compensation? Like change current one.
Direction of current, okay. You see that we are considering, say, rise input. How the change in impedance is considered? We have considered that the impedance has been changed from ZL plus delta ZL. Okay, ZL plus delta ZL. Change in impedance is there, and because of this change in impedance, we have calculated the current delta I. How we have calculated this current? This I equal to final current minus initial current. Okay, Final
Yes.
current minus initial current. So that becomes this much. It is minus Vc by Vthevenin plus ZL plus delta ZL. How you calculate Vthevenin? Sorry, Vc. Vc equal to initial current into change in impedance. Okay. So consider this expression. Current will be minus, means polarity of Vc will be such that it is opposing the current I, delta I. What is the direction of delta I? In this case, you see that we have considered delta I to be in the same direction. In this direction, delta I is flowing I1 minus I. That means delta I is in this direction, in the direction of I. Okay. Since it is in the direction of I, you can say that it is Vc is written here. We have written equal to minus Vc by this thing. How we have written the Vc? It is I multiplied by delta ZL. That means Vc has to be, magnitude of Vc is this much, and what will be the polarity of Vc? Vc will be such that this I is opposed. Why this I is opposed? Because of the minus sign. That means Vc will actually push a current, deliver a current in the circuit in such a direction that I is opposed, and that is indicated by this minus sign. Okay.
Yes.
That's why I is here and Vc has been shown here to be minus. Because in this circuit, how will you reflect this minus? That is reflected by this polarity here. Alright. We are
Yes.
showing delta in this direction, but polarity of Vc is like this. And this polarity here, minus sign has been included. How? Because it indicates that this I is being opposed. I is being opposed because positive polarity here means this will deliver a current in the opposite direction. I was flowing in the direction of delta I. All right.
Yes.
Any other question, anybody? আর কেউ কোনো জিজ্ঞাসা আছে বলো? In the example or in the theorem. Anybody else? Any question? Obviously, we may consider a more complicated circuit. Here, the circuit considered is very simple. Okay. So better you consider another example having more branches and consider the current to be changed in impedance is changed in one branch only. There you apply this theorem, then you can have a better idea. Okay. To make the analysis simple, to make the discussion simple, we have kept the circuit here to very small. Okay. Now see whether this is clear to you or not. Everybody.
স্যার স্যার বলছি এখানে যে ইনিশিয়ালি ফিগার 24.1 এ যেটা 1 ভোল্ট দেওয়া আছে
24.1 হ্যাঁ বলো।
হ্যাঁ ওই 1 মানে ওখানে মানে ওটা তো একটা ইন্ডিপেন্ডেন্ট দেওয়া, মানে এখানে যদি ডিপেন্ডেন্ট কোনো সোর্স থাকতো তাহলেও কি মানে সেটা রিমুভ হয়ে গিয়ে একটা ওই ভিসিটা আসতো?
না, ডিপেন্ডেন্ট সোর্স থাকলে তাকে করতে হবে। as in case of Leibniz theorem, dependent source cannot be replaced. Dependent source has to be retained in the circuit. Okay, তাকে সরানো যাবে না, because this depends upon some current, some voltage. কাজে যদি এখানে যেই ব্রাঞ্চ গুলো আমি পরে থাকবে তাদের মধ্যে ভোল্টেজ কারেন্ট থাকলেই ডিপেন্ডেন্ট সোর্স টা অ্যাক্টিভেট হবে। How shall I remove that? That cannot be removed. Okay, independent sources will be removed, not the dependent sources.
না মানে না মানে স্যার ইনিশিয়ালি তো যখন মানে স্যার এর আগের পেজে একবার যান, আগের পেজে মানে এখানে হ্যাঁ স্যার এখানে তো আপনি মানে ফার্স্টে মানে যদি লোড মানে জেডএলটা হচ্ছে লোড রেজিস্ট্যান্স, তো আগে ওইটার অ্যাক্রসে যদি আমরা থেভেনিনটা বার করে নিচ্ছি তখন তো আর মানে ডিপেন্ডেন্ট ইন্ডিপেন্ডেন্ট যায় আছে। এমনি বার করে নিচ্ছি আমি পুরোটা মানে আমি ধরা যাক বাকি সার্কিটটাকে এইভাবে ডিনোট করলাম, আগে এবার দেখালাম। ওকে, that circuit has been shown by Thevenin and Z Thevenin. That means the circuit is as if there. ওকে, আমি সেটাকে যেন আমি আর বার করলাম না, কারণ সেখানে যখন একটা তোমার ইয়ে থাকবে, একটা ডিপেন্ডেন্ট সোর্স থাকবে,
তখন তো ডিপেন্ডেন্ট সোর্স থাকা অবস্থায় তোমাকে কি বলবো থাকা অবস্থায় বাকি ক্যালকুলেশন গুলো করতে হবে। অর্থাৎ আমি দেখাতে চাইছি এখানে যে একটা সার্কিট রয়েছে, তার থেভেনিন ভোল্টেজ এখানে রয়েছে, ঠিক আছে, কিন্তু থেভেনিন ইম্পিডেন্স যেটা রয়েছে অ্যাজ ইফ দ্য টোটাল ইম্পিডেন্স ইজ দেয়ার, আমি সেটাকে পুরোটাকে না এঁকে যেন একটা সিঙ্গেল ইম্পিডেন্স দিয়ে দেখাচ্ছি, ওকে। কিন্তু ডিপেন্ডেন্ট সোর্স যখন তুমি থাকবে, অর্থাৎ তাহলে তুমি এখানে কি করতে পারো, তোমাকে তাহলে যে এটা কম্পেনসেশন সোর্স লাগাতে গেলে তোমাকে একবার থেভেনিন লাগিয়ে আবার করতে চাও, সেটা তো দরকার নেই। ইউ কিপ দ্যাট ইনটেক্ট এন্ড সলভ। মানে একবার থেভেনিন লাগিয়ে থেভেনিন ইকুইভ্যালেন্ট করলাম, আবার কম্পেনসেশন লাগালাম, দ্যাট উইল নট বি দ্যাট মিনিংফুল। বুঝতে পারছো? আমি যেমন বুঝতে পারলাম যে তুমি যেটা বলতে চাইছো যে আমি কি তাহলে প্রথমে থেভেনিন ইকুইভ্যালেন্ট বার করে নিয়ে করবো, না সেটার দরকার নেই, এটা কেন করবো? বুঝতে পেরেছো তো? দ্যাট ইজ নট নিডেড। To make the analysis simple, I have shown that a complicated circuit may be there that I am representing here by this. Okay? But you need not find out the Thevenin impedance. You need not find out the Thevenin voltage. কারণ তাহলে পরে তোমাকে পুরোটার একবার Thevenin equivalent বার করে নিয়ে তারপর করতে হবে. That is not needed. All right? Any other question?
So you told that like impedance will change from Z plus delta ZL. So it will change every time, or like will become constant after changing?
No. Even আমি বলছি say the situation is like that. Say you know you have solved a circuit at an initial condition. Okay, at a single instant you have solved the circuit. Now you have to examine what will happen if a particular branch you are designing a circuit basically. So that for that reason you have solved the circuit first, and now you want to check what will happen if a certain branch impedance is either increased somewhat or decreased somewhat, will be the effect. Then this theorem will be applicable here. It will be important to understand that condition.
Okay.
You want to check what will be the effect of the modification of a circuit branch. কোন সিচুয়েশনে সেটা লাগতে পারে, বেসিক্যালি when you are basically designing a circuit, তাই তো? সেই কন্ডিশনে যেন তুমি এটাকে, তখন যদি মাল্টিপল সলিউশন লাগবে তখন তোমাকে ডিটেইলস এর মধ্যে আর যাওয়া দরকার নেই। দেন ইউ ক্যান ইউজ দ্য ইনিশিয়াল solution at the first instant, and then use compensation theorem to find out the modified solutions. Under that condition this will be applicable. Okay. আর কিছু এখন any further question? So anybody? So if there is no more questions, so I shall do. I have more exam.
Sir, figure 24.2 এর
20 এখানে বলো।
পাশে আই ডেল্টা বাই ডেল্টা আই এর যে ডিনোমিনেটর 8/9 টা আছে, ওটা কি ইকুইভ্যালেন্ট থেভেনিন ইম্পিডেন্সটা?
কোনটা 8/9? হ্যাঁ 8/9 টা কি আমি এখানে বার করছি তো, ডেল্টা আই উইল বি ইকুয়াল টু দিস ভোল্টেজ, তাই তো? দিস ভোল্টেজ ভিসি ডিভাইডেড বাই, আমি যদি লিখতাম ভিসি ডিভাইডেড বাই দিস ইম্পিডেন্স প্লাস প্যারালাল কম্বিনেশন অফ দিস টু ইম্পিডেন্স লিখতে পারতাম তো। আমি লিখছি কি ডেল্টা আই ইকুয়াল টু মাইনাস লিখছি। কেন মাইনাস লিখছি? কারণ আমি যে কারেন্টটা বার করছি দ্যাট ইজ অ্যাকচুয়ালি ফ্লোয়িং ইন দ্য ডিরেকশন অপোজিং delta I. আমি শুরু করছি delta in the downward direction, but the current delivered by this source is in the opposite direction. That's why this minus. Now the value of BC is written here by how much will be the current? It will be this current plus parallel combination of these two impedances. Okay.
8/9.
All right. So 2 plus parallel combination of these two, 8 and 1 means 8/9. ঠিক আছে?
হ্যাঁ স্যার।
আর কোনো কোশ্চেন আছে কারো? ওকে, যদি না থাকে তাহলে পরে কি হবে? if no other question then I have more problems here to be discussed, but before that it is better if you have some কি বলবো better understanding of the theorems, better understanding of superposition, then Thevenin, Norton, all these things. Okay. So superposition already you have studied. So what I can do, this is basically particular an example of application of Thevenin's theorem. Okay, so I shall discuss these solutions, but in the next class let us do all these things. So if necessary, I shall discuss the reciprocity, superposition first, and then discuss these examples. It is better to do the next class. So in the meantime, you rather go through the or little bit of exercise is needed on your end. You consider some examples, solve for Thevenin equivalent and Norton equivalent, and try to have solutions using compensation theorem also, so that we can next consider these examples. Okay, so next day also we shall be solving problems on network theorems, more problems and more theorems also on network theorems in the next class. Okay, so in the meantime, it is better if actually that initial condition is handled in the Laplace transform classes. How much is done on the other side? Laplace transform it has been started or not?
No, sir. Laplace transform is not started. Sir has given a preview of the signals and systems, and that's that's how much it has been done on that class.
Signals and system, basically Laplace transform has been started, not applied on circuit.
Sir, not yet.
No, sir.
Not
No,
yet
sir.
started.
Not yet started, sir.
From next class onwards, it will be started, most probably.
Yes.
Okay. Okay. So let me see. So but Laplace transform has not been introduced to you at all from mathematics classes also. It has not been introduced, na?
Yes, sir.
Okay. First year you have not done Laplace transform.
No, sir.
No,
স্যার
sir.
স্যার অ্যাকচুয়ালি ওটা সিলেবাসে ছিল কিন্তু মানে ক্লাস হয়নি বলতে barely দুটো class হয়েছিল।
Okay, let me see. Okay, if necessary, then I shall have to do, because I know otherwise I cannot proceed on these topics. Okay, so better I do in the next class. Okay, all right.
Okay, sir.
Okay, so today, then next class again will be on. Today is
So Friday.
Friday will be the next class. So the one question one of you have raised, so I shall verify this and then this class in the next class. Okay, all right. So now let me make the roll call and then stop. Okay. Okay, I can see your name now. Okay. আচ্ছা তাহলে বলো তো তোমাদের আর কি কি ক্লাস হচ্ছে? সেকেন্ড ইয়ারে ধরো আমার ক্লাস হচ্ছে, and what are the other classes being held?
স্যার আমাদের সার্কিট আপনার সার্কিট থিওরির ক্লাস তো হচ্ছে, আর একেটি স্যার করাচ্ছেন, আর মেজারমেন্টস এর দুটো ক্লাস হচ্ছে, তারপর মেশিনস এর দুটো, আর ম্যাথস এর দুটো, থার্মোডাইনামিক্স এর একটা, এরকম টোটাল মানে যদি সব ক্লাস হয় তাহলে একটা উইকে 13টার মতন ক্লাস হবে।
আচ্ছা, তাহলে তোমাদের কটা হচ্ছে একটা উইকে?
হ্যাঁ স্যার,
মোটামুটি সবকটাই হচ্ছে, তাই তো?
হ্যাঁ স্যার, হ্যাঁ স্যার।
Okay. Okay, then Aniket Day.
Yes, sir.
Then Anushmit S. তাই লেখা আছে Anushmit. Anushmit.
Present, sir. Present, sir.
অর্কপ্রভ মজুমদার.
Present, sir.
অর্পণ কুমার চাকি.
Yes, sir.
অর্পণ মন্ডল.
Present, sir.
অরুণিম পোদ্দার.
Present, sir.
বিদীপ্ত রায়.
Yes, sir.
বিনয় সরকার.
Yes, sir.
Then বিশ্বজিৎ রজক.
Yes, sir.
দানিশ আলম.
Present, sir.
দেবার্ঘ দত্ত.
Present, sir.
দেবার্ঘ নন্দী.
Yes, sir.
আচ্ছা, দেবার্ঘ নন্দী, দেবমাল্য দত্ত বললাম, দেবমাল্য দত্ত.
Yes, sir.
হাজারে নুভি. হাজারে নিউভি. কে আছে বলো তো? হাজারে HAZARE কে? হাজারে নুভি, I don't know. Please respond if you are here. ইমানুল হক,
Yes, sir.
ইমানুল হক, ঋষিত ঘোষ, ঋষিত ঘোষ কি বললাম আগে? এটাই মধ্যে পাল্টে গেছে। ঋষিত ঘোষ, আচ্ছা, ঈশিতা ঘোষ,
Yes, sir.
জাকওয়ান শাকিব,
Present, sir.
কাজী গালিব,
Present, sir.
ময়ূক বিশ্বাস,
Sir.
ময়ূক
Present, sir.
বিশ্বাস,
Present, sir.
হ্যাঁ, মোহাম্মদ জাহিরুদ্দিন,
Yes, sir.
আচ্ছা, নেহা আগরওয়াল,
Present, sir.
নির্মাল্য নন্দী, নির্মাল্য নন্দী, নির্মাল্য নন্দী, পার্থ হাজরা, পার্থ হাজরা, পবন অগ্রহারী, আচ্ছা পার্থ হাজরা বললে, ওকে, পার্থ হাজরা, দেন পবন অগ্রহারী, পার্থ হাজরা প্রেজেন্ট, বুঝতে পারলাম, ঠিক আছে। পীযূষ আগরওয়াল,
Yes, sir.
দেন ওকে, প্রিয়ব্রত সিংহ, প্রিয়ব্রত,
Yes, sir.
প্রণয় প্রামাণিক,
Present, sir.
রাজাবাবু আলম, ওকে, রাজাবাবু আলম, ওকে, রাজাবাবু আলম দুবার দেখাচ্ছে কেন? রেজওয়ান শেখ,
I am using laptop and mobile too.
ওকে ওকে, রেজওয়ান শেখ,
Present, sir.
রেজওয়ান, ওকে,
Present, sir.
সমর্পণ ব্যানার্জি,
Yes, sir.
সর্বদা মিত্র,
Yes, sir.
সত্যজিৎ জানা,
Yes, sir.
শঙ্খদীপ ঘোষ,
Yes, sir.
শঙ্খদীপ, সেজুতি কর্ম